Hello, by the end of today's lesson, you should be able to take data from a table or at least 2 points and write it in slope-intercept form. So make sure your notes are set up in Cornell note fashion, and we're going to start off with a data table, okay? So with the data table, we're going to have X and Y, and we're just going to take 4 data points. From this table, we are going to write an equation in slope-intercept form. The first thing we need to do is find the slope and find the intercept. The slope can be found in a couple different ways. So slope can be found with rise over run. It can be found with the equation y2 minus y1 over x2 minus x1. Or you can find it change in y over change in x. All of these things are just different ways of saying the same thing. So rise over run works the best when you have a graph. So if we had a coordinate plane and we were able to graph this, and it went up by 40, we would have a point at 0, 20, 155, 290, and so on, okay? We don't have a coordinate plane that has these large of a numbers, plus graphing it first and then finding rise over run doesn't really make the most sense because it would just take too long. So instead, when we have a table, we're typically going to use this one. So I'm just going to put a little star next to it. This works if we have 2 ordered pairs or if you have a table, because here are some ordered pairs. And we're just going to choose 2 points from this table. I like to choose ones with the smallest numbers because smaller numbers are easier to work with. So the 2 points we're going to choose are 0, 20, and 155. And now we're just going to fill them in here. So y2, 55, minus 20, over 1 minus 0. So we get 35 over 1, or a slope of 35. Change in y over change in x is also easy in a table as long as the table goes up the same amount. What I mean by that is from here to here, that's a plus 1. We have another plus 1 and another plus 1. So it's easy to see. So this would be plus 35, and from here to here, we are also adding 35. From here to here, we're adding 35. So if change in y, which is down here, is 35, and the change in x each time is 1, then we also get a slope of 35. Now remember, slope-intercept form is y equals mx plus b, where m is the slope, b is the y-intercept. So we know the slope, so now we need to look and find the y-intercept. Remember, the y-intercept is the y value when x equals 0. 2 ways we can do this. We can go back up to this example, delete one of these points, and put the y and the x, and then solve for y, okay, to get it in this form. Or, because our table already tells us that when x equals 0, y is 20, we know the y-intercept. It's 20. So we can actually just look at the table in this case. Y equals, our slope is 35, so 35x plus, and our y-intercept was 20. Y equals 35x plus 20. That's it. My suggestion, find another XY table from your textbook, use this equation here to find the slope, and then write the equation for that line in your summary to prove that you know how to do this. This is on page 16 of your notes. Thank you.